we go to the moon. We go to the moon. And the other thing, not because they're easy, but because they are hard. This week, we celebrated Kennedy's iconic speech. 60 years ago in Rice Stadium, he called our nation to the moon. We go to the moon again. So we go to the moon again in 2 weeks' time, hopefully with Artemis 1. Artemis will be launching on September 27th at about 11:37, hopefully. And they will go on a almost 39-day journey around the moon to kind of test the whole rocketry. And then the next time we go up, there'll be people on board. And then the third time it goes up, we will be walking again on the moon. Kentucky goes to the moon. This particular flight, Artemis 1, we have we have warhead that are going on, lunar ice cubes, which they're going to be looking at water sources on the moon as they do a flyby. And then we have red wire, which aren't technically Kentucky, but they're just right outside of Louisville, so I claim them. They're close enough. And they're going to be doing some type of powering in cameras. And let's see, the exact wording is, they are going to be providing an array of internal and external inspection and navigation cameras comprising the Orion camera system. So Kentucky goes to the moon. Why are we doing space for Kentucky? Number one, social support. This last spring, I went to the Space Tourism Conference, and it had been people I had met via Zoom. And it was like going back to a family reunion. And I'm sure that all of you can relate that when you start to talk to people about space, you kind of get a blank look, like, and they just give you this blank stare. Even if they're interested in it, they just don't know how to respond. And then that kind of tends to keep you a little quiet. It does me. I tend to back off a little bit after a certain amount of conversation. So we need each other to be able to have conversation, to be able to stimulate each other and to help give an outlet for social belonging. So that is the main reason, is social support for the companies that are doing something in space in Kentucky. Second one is to inspire and be inspired. Going to space is hard. And I know you guys know that. It is hard. Being in business is hard, even if you're not going to space, but then you add space on top of it, and it is hard. We need the inspiration off of each other. We need to know that we're not in it by ourselves, and we need to tell each other, you can do it. We need to learn and share our knowledge. When we're sitting there having conversation and we're learning from each other, when you don't have that tribe to learn from, you kind of tend to start to stagnate. So this particular forum is so that we can learn from each other, and then we can tell each other what we know and build each other's base. Business networking. You may have something that you can use, and we don't know that each other can work with each other's equipment. So business networking is huge. Kentucky has one of the largest aerospace manufacturing in the nation. Before COVID, it was $14 billion a year in aerospace manufacturing. That's a lot. And we didn't even know that it happened because there was no community up until KAIC. And that's when they started to discover that. We were number 3 in the nation for aerospace manufacturing exports, and nobody knew about it. We want to tell each other, you can do it. You're doing something hard. We need to be that support so that when Somebody wants to go to school for astrophysics. They have somebody to say, you can do it. And here I know somebody. And then we need to share tools and our connections. One of the things that we can do is, with the Zoom, we're on Zoom right now, is we can have people come in and give presentations that don't even live here, that don't even live in this country. Most of the people that I work with aren't in Kentucky. They're not even in the US. They're abroad. I mean, it's a global world and it's awesome and amazing. These are the companies, and we need to add Twiggs to this. So we've got Space Tango, we've got NASA Kentucky, we've got ClimaVision, which they're doing monitoring, and they're out in Louisville. And then we've got Redwire, that's going to the moon, and Moorhead, which is going to the moon. Moorhead does small satellites in a college program. NASA Kentucky is out of the UK program, and a lot of the people that I've interviewed for my podcast, they've done things with UK. Strata Dynamics, they did a UAV, which is it's a flyer that goes up into the stratosphere. They were through UK. The gentleman that I work with in Ecuador, he has worked with UK, and they're doing a spaceport and a STEM program with kids in Ecuador, and they want to connect with Kentucky kids. Now, can you imagine the Kentucky kids that are in school and getting to work with Ecuadorian children? How will that impact their thinking going forward? They will never think this 50-mile radius. They will think globally. And that's where everything is going, is we're one big world. So if you guys, I don't know, come on up.
Everybody or one by one?
One by one is fine.
Hi, I'm Matt Kraft with Twiggs Space Labs. Co-founded a company with Bob Twiggs about 4 years ago. Professor Twiggs used to be a professor at Stanford University and then a professor at Moorhead State University. And his passion has always been STEM education. So one of the goals that he wanted to do was to start a company that could develop technologies to teach students about systems engineering and satellites. And so we partnered with Virginia Commercial Spaceflight Authority about 3 years ago and did 2 missions with them, flying ThinSats to the international, flying on an Antares rocket that was going to the International Space Station. And so we launched on our first mission. We launched 60 ThinSats from the second stage of the Antares rocket. And then about a year and a half later, we launched 30 ThinSats. During that period, I think we worked with about 70 to 80 different schools that were involved in the ThinSat programs. We worked with a lot of universities in about 10 or 11 different states. Moorhead State was one of those universities that we worked with. And over the last 2 or 3 years, we've really focused on developing a lot of new hardware products that teach students about systems engineering and satellite subsystems. And I'm going to turn it over to Professor Garcia, who is one of our partners at Twiggs Space Labs, who is our Chief Technology Officer and has developed a lot of these products that we're now using in the classroom across the country. Thank you.
Hello, everyone. My name is Jose Luis Garcia. I'm from Moorhead State University. As Matt said, well, at Moorhead State University, we have a program for developing a space system engineer program in which the education is focused on a hands-on projects. Then the students learn about the space system engineering just working on real projects like Lunar Ice Cube. Lunar Ice Cube is a satellite that will be flying to the moon in a few days on the Artemis 1 mission just to look for ice on the moon. If we find ice, that means that there's water, and if we find water, we know that we can support so many things on the moon. Then, in addition, with this hands-on project, as Matt mentioned, we support the development of new tools, new kind of elements that the students can use to learn about the spacecraft, STEAM education. Then we are very happy to support all this process for the education. And that's it. Thank you very much.
Did you want to come up and talk about school? It's okay.
She's my, yeah.
Okay. Awesome. Well, hopefully in the months coming, we will have more meetings. Every month, we will have a meeting to build our tribe in Kentucky. Now, the space economy. This particular one is the Air Force One mock-up for the suborbital subsonic transportation that is coming online. Why are we even interested? And we start off with money because that's where most things begin, is the money. In 2019, it was $423.8 billion industry. And this was research, exploration, and things that utilize space. Bank of America, a forecast saying that it could grow up to $1.4 trillion by the end of the decade. Now, to give that a perspective, the gross national product for Australia was 1.3 trillion. So that's more than an entire country. And this is a conservative effort. Forbes sees it as a $10 trillion industry by 2030. Now, George Pullen, which is an economist, says that it could be all the way up to 14 trillion, and here's why. Back when we were looking at cell phones, if you looked at the amount that cell phones generated in 2001, it was like $190 million. Well, now that is over double this year. Nobody saw the smartphone coming. In 2001, they were talking about it declining. They were looking at a slump. And there's not been a slump since then. The smartphone has impacted how we do business. It has impacted how we talk, communicate. It has impacted how the world does things. So we are going to see so many things come online in the next 8 years, and some of those we will not see coming. Things that, if they happen, will impact this particular amount is if pharmaceuticals start to send up their own space stations to do their own manufacturing with different pharmaceutical medicines and disease research. That's going to change the game if you have that many private space stations. As it is right now, we're going to have quite a few in the next few years. It is expanding more than 70% since 2010. Non-government spending rose 7.7% in the US, and space budgets grew by 9.5%. And this is all was the stats that I started in February. 10,000 companies are in space, and they're valued over $4 trillion as of the beginning of this year. The US saw record number of private flights, private rocket launches in 2021. We had Inspiration 4, we had Blue Origin, we had Virgin Galactic. All those did private astronaut flights. NASA had a private astronaut flight that went on the IS, the International Space Station, this past February. So launch costs have drastically reduced. Back during the space shuttle era, it was about $27,000 per pound to launch into space. SpaceX has brought this figure down to $700 per pound as per the International Space Station study. 51% of small sats are being developed in the private sector, and 67% are developed to provide commercial services. The small sat is huge. Workforce. This is why Kentucky needs space, is to develop jobs. And these are not just average jobs. These are jobs that see more than the average pay, even for STEM careers. The US space sector added more than 5,000 employees in 2020. with 140, almost 148,000 workers, with an increase of 3.2% despite the pandemic. Space grew even when everything else was shut down. And not many industries can say that. Now, as far as STEM careers normally pay about 95,000 average. Now, these figures here lately with the Great Resignation, there's the what salaries are going for is a little bit different, but this is what the stats were at the beginning of the year. Space STEM is 123 average $1,000 a year. Why Kentucky? And we got the next one is what if Kentucky did not have the vision for the aviation industry? We have built a strong aviation infrastructure in Kentucky. We have 2 international airports. We have, what if they said, well, you know, there's 13 well, there's actually technically 14 FAA approved spaceports in the United States. So what if we only had 14 airports in the United States? How would we get things moved? We would not be able to utilize it. What if we said it's only for the rich? Well, commercial aviation was only for the rich when it began. And we bring prices down. That's what we do. And then more people can access it. There are over 600 aerospace business manufacturing companies in this particular state. Like I was saying earlier, we are number 3 for aerospace manufacturing. Okay. And it was $12.4 billion in 2018, and it was $14 billion in 2019. Now, we have logistics in Kentucky. We have major highways going through it. We have a river that surrounds a good portion of the state. This particular river goes to the Mississippi. The Mississippi goes to the Gulf. The Gulf goes to Cape Canaveral. So maybe we can't ever launch a rocket here from Kentucky, but we can put it on something and we can get it to where they do launch without taking it up into the air. Sometimes when you take equipment up into the air, the atmosphere can weaken it. But we have a river. We also have international airports. We have one here and one here. We're centralized. We're in the middle of 34 states. We can be almost anywhere in very short time. And we also have a lot of railroads. Now, this is why we need space in Kentucky. These are the stats of what we have in Kentucky. We are 38th in education out of 50. We are 43rd in employment rates. We are 12th in the country for drug use. Our kids are growing up and not having anything to inspire them except for more of the same. We've had the coal industry just collapse on the eastern side of the state. And drug use is rampant. There is no hope. There is a stat that I heard from a parent this week that I found especially disturbing. In the military, his son is just got his first duty station, and they're in Poland. 4 service members that were young committed suicide since they've been there, and it's only been a couple months. 4 in a unit. People see this as an option. These kids have nothing to give them juice, to get them excited about approaching their day. And that is a major reason why we need space. Is because, can you think of another industry that's as exciting as space? That's as inspirational as space? Now, we're 12th in the state, but we're surrounded by states that are number 10 and number 14. They're high for drug use as well. We're 43rd for economy. We need industry here. We need jobs here. We need good jobs. And this is the one that bothers me as well. We're 50th in the nation out of 50. We're bottom for the worst state to find a job as of 2021 compared to 35 indicators. We are the worst at thinking about getting jobs. Now, this is my concept for a spaceport. This is just a concept. These are buildings here that have incubators. There is like an incubator. It's got training for STEM. It's got training for astronauts. It's got analog training, which is basically a mock training for the moon or Mars. We've got mine shafts and things that we can set up analog training that stimulate some of the ideas for going to the moon. Some people are thinking about putting us in lava tubes on the base on the moon. So why not try it out down here? And then it can be weather monitoring, earth kind stuff. It can be companies that are doing research. This would be like a convention center. And it would also be to where you have an observation deck that can overlook the runway, which would host horizontal launch situations. This would be a suborbital supersonic aircraft. They're going to need someplace to land and take off. And then there's also other options for horizontal launch that are like the Virgin Orbit, where they have a rocket strapped underneath their wing, and we can take off on a regular plane, get out over the ocean, shoot it off, and put things into space.
And I guess it's missing high altitude of balloons opportunity.
Yes.
Because we can have something about high altitude of the area.
And drones. We can augment it with drones. Drones don't necessarily go up to the space, but like with Stratodynamics, they can go very close and then shoot it off from there. Or they can test robotics for when we get into space. We're going to be doing a lot of manufacturing with robotics out there, which are drones. So they can house drones because we're going to have the airspace. You know, that's an important thing. And Kentucky has the possibilities of the airspace, so we can house this type of thing. We just need a long enough runway, and we need to make it happen. Anyway, so what does a spaceport do for the economy? Spaceport America, they have forecasted that it will be worth $1 billion by 2024 in direct and indirect and economic impact to that area in New Mexico. They had 33 million in direct stimulus. It has added 150 good jobs. And New Mexico paid for that particular spaceport. The state of New Mexico is a government-run thing, just like our highways are here. And they were able to pay off the investment of $220 million during the 2013 year, and they started, I believe, in 2005. So within a very short amount of time, they paid off what it cost to build. And Virgin Galactic, they estimate that it brings in $400,000 to the local economy every time they have a launch. So that's just one example. I have a couple of copies of this with me, but it is online as well. I did a report for why Kentucky needs a spaceport, and it has a lot of this data in it. Why space? Go ahead. Space station. We have a lot of space stations getting ready to happen. There is so much chalked into the next 4 years. It is mind-blowing what is going to be going up into space. So we have 4 space stations that are NASA space stations getting ready to go up. And that includes the one that is going to be taking over the space station, Axiom. So there's 3 other ones that are going to be getting ready to be launched in the next several years that are going to be doing testing. You have the orbital reef that is also going to be going up in short order, which is a whole community of space station things. Dream Chaser is going to be going from space station to space station and then bringing what is manufactured back down to Earth in a safe manner. We have, these are worth $415 million. And then we also have the Space Entertainment Enterprise getting ready to go up in 2024, which they're going to be doing a movie and they're going to be doing sports in space, in a space station up there. So those are just these. There's other ones that are talking about going up, and there's other companies that are coming up with inflatable parts that can set up space stations in a matter of no time. Another concern is defense. Russia and China have been doing some activities that give us a little bit of concern. One is they conducted anti-satellites. November of 21, Russia did a anti-satellite test that did a huge debris field full of thousands of little minute particles that have made it to where a lot of the satellites have had to change trajectory, including the ISS. The International Space Station has had to move their orbit to avoid this debris field, because when you're out in space and you're in the International Space Station, you're going about 27,500 miles per hour around the Earth. To give a little bit of context, a bullet goes 1,800 miles per hour. So this is over 8 times faster than a bullet. The debris is very hard to catch. It is very hard to work with, which is an industry that is coming on board as well to catch that. China has launched some satellites that are capable of dismantling or destroying other satellites in orbit. They tested nuclear-capable hypersonic missiles. Remember that supersonic suborbital transportation that we were just talking about a minute ago for Air Force One? Well, China is also developing those aircraft, and those aircraft are going to be able to supersonic suborbital flights ride the orbit around the Earth. So they're able to go 27,500 miles per hour, and they're going to be able to go anywhere in the world in an hour and a half. That includes hypersonic missiles. In 2022, when the tensions started to grow with Ukraine, Russia threatened to bring down the International Space Station on a strategic target because they handle that part of the ISS. They have since are going to be doing their own space station, and they're going to be departing International Space Station. So tensions are increasing with superpowers that want to own space as well. Environmental concerns. The climate crisis is becoming a very real thing. Just in Kentucky alone, this year, we have dealt with a tornado like we have never seen before. That was 5 miles wide and bore a swath of 250 miles through western Kentucky, annihilating towns, just wiping them off the map. And then, if that wasn't enough, and this was December of last year of 21, this fall, we had epic flooding that was almost like a tsunami going through the area and wiping out roads, picking up full homes and putting them in different places. The devastation has been intense. And this has never been something to this degree that we've had to deal with. And Kentucky has seen too. This does not count the fires that are happening on the West Coast on a yearly basis now. The one we had last year, all up and down the coast. It was intense. And then we've had record flooding in Pakistan just in the last few weeks that will take months for the water to recede. And then over the summer, we had temperatures in Europe like we have never seen before that killed thousands of people. The climate crisis is starting to rear its ugly head, and it's time to do something about it. Well, what we do about it is what we can see. And what we can see and measure comes from space. That's how we're going to solve it. Plus, as we go forth in space, like with the International Space Station, it's a miniature ecological bubble that we learn how to breathe, and we learn how to clean water, and we learn how to survive. As we go through and go from the moon to Mars, we're going to need those little ecosystems that can keep us alive. That technology will come back down here and help us with our little bubble of a planet and help heal it. So all that technology comes back here to help us. The monitoring of it, we are able to see the different types of pollution. We are able to see holes in the ozone. From space, we were able to detect holes in the ozone back in years ago, and we were able to take care of all the chemicals in the aerosols to make it to where they are healing now. And they're expected to be, one is expected to be gone by 2050. It's shrinking and getting smaller. And that came from space. Fuels. Technology for exploration equals cleaner fuels. Because last time I checked, there was no dinosaurs on the moon. Now we may find otherwise, that there may be a long time ago, but fossil fuel is not going to be an option, which I know a lot of the other fuels are not fossil fuels. But the energies and the power that we are going to need to go from planet to planet, we're going to have to find in situ. So we're going to learn new technology that we're going to be able to bring down here. Solar is one of those technologies that we've been able to bring down here. We've been able to refine it through space with the satellites and with a lot of like International Space Station. Space industries, we have a lot of things that we may not even think about as an industry. We have the suborbital supersonic aircraft coming. They're going to need a point-to-point infrastructure around the world in order to happen. Now, to give you guys an example of how long it takes to build something of a spaceport magnitude to be able to house this kind of thing, we have a general aviation airport that it took 16 years of negotiation and getting the budget in order to see the Gallatin Airport even break ground. So we're not talking about something that's going to be soon. You know, we're looking at 20 years out. What are we going to see in the next 20 years by the time we get a spaceport even built? So cargo to and from space. When we manufacture things in space, it's bigger crystals, it's cleaner. The fiber optics is amazing. The clip, and I actually have a picture in here that we'll show here in a minute. But we can manufacture things in space. Red Wire, which is TechShot, they have done technology where they 3D print human parts made out of tissue. We'll be able to take stem cells from yourself, which is on your skin, and print you a heart up in space. Now, why can't we do that down here? It's because we have gravity. When you're 3D printing with cells, it's almost like 3D printing with water. It just collapses down itself, and it doesn't have a time to set up a structure. But in space, that structure can happen. They did a miniature heart, and it beats. So we're going to be able to manufacture things like that and bring it down here. How is that going to change everything? Launch vehicles are going to be a big deal, getting stuff to and from. Launch services, that's something Kentucky can offer too, is when there is a rocket going off or there is a type of thing being launched, we can help with the launch services to monitor the traffic, monitor the debris, and make sure that the windows are viable. Satellite services, communication. Everybody's got a cell phone. That comes from space. It's amazing how many people don't know that they carry space in their pocket. You know, from the communication to the internet to the global GPS. Being able to use a map or check your weather. That all comes from space. Computing. As we go forth in space, there's a lot of data that is coming from space, and we need to figure out how to make it more powerful. So computing will change quite a bit as we go forth in space. And navigation, GPS is amazing. They're able to detect when the Earth shifts by 1 inch. So we can see earthquakes and things happening with GPS. It's amazing, in addition to finding our way to the Lexington Library. This was how much the economy was in satellites in 2019. It was worth $366 billion. It's the largest sector of space at this point. And this is how many satellites have been launched. You can see this is 2011. Look at the difference. We've been hitting record numbers of satellites going into space. Earth observation, like I was talking before, disaster management, pollution, weather forecasting. Agriculture, we are able to see what crops need water. They're doing a huge study on the ISS right now for cotton, and they're able to see what cotton plants are stressed and which ones need water. So we're able to utilize what water we have in a better way. And resource management. So disaster prevention, cleaning our water and our air, energy, agriculture, and aquaculture will need to be enhanced as we go forth. We're going to need food, and we're going to need to learn how to grow it. And as we learn how to grow it in space, it'll impact farming practices down here. And we talked about the aerospace manufacturing. And space debris is a huge industry that is coming online. They're companies that are looking at the debris fields, and they're looking at taking the materials from the old satellites, the dead satellites, and turning them into powder that can be 3D printed into other materials. So we're going to be able to take our space junk and make our space equipment. So that is awesome. This is an exact example of the Z-band, which is the fiber optics. You can see this one is manufactured on Earth, and it's real cloudy. This is what it looks like manufactured in space. The crystals are cleaner, they're more pure. This is why disease research is also something we can do from the International Space Station, because the disease crystals are bigger, and we're able to see them better and research them better. You went the wrong way.
Yep.
Okay. Pharmaceutical manufacturing, which Space Tango is a very big part of, which is a Kentucky company. They are looking at mixing different particles to where, like, if we mix a bunch of chemicals down here on the planet, they're going to mix a certain way. Once we take gravity out of the situation, they mix differently. And then we can create different compounds and different cures. So they're doing all kinds of research into osteoporosis because astronauts have a very big problem with this. Well, all that research for the astronauts is coming back down on planet and helping people with osteoporosis. Parkinson's is a huge research category up on the International Space Station. Asthma, being able to breathe better, autoimmune issues, artificial retinas for macular degeneration, which is Space Tango is working with. Vaccines. The vaccine that you got for the coronavirus, COVID, came from research that was done on the International Space Station. Testing of tissue chips. This is huge. They're like little thumb drives, and they live up on the International Space Station in a heated environment. And on each of these thumb drives are different cells. So we're able to take liver cells or pancreas cells or brain cells, and we're able to test them with different medications and see how those particular cells react to the medication. We're able to do testing, and not human testing, but very close to it, where it's almost like human testing without human. So awesome stuff. Surgical robots, ultrasound machines, CT scanners, and bioprinting. have been huge industries as a result of space. Space tourism, this is the space perspectives we were talking about earlier. So space tourism has been big with Blue Origin, Virgin Galactic, and SpaceX all going up this last year. The International Space Station had their very first private astronaut mission this February. And hotels and other tourist experiences are online to happen. That's one of the space stations that are going up, is a hotel, so that people can be exposed. There's all kinds of events that we can have in Kentucky that are focused on space. This is the space hotel that they're proposing goes up in, I think by 2027. It's before the end of the decade. And this is going to spur on all kinds of industries as well. We have spirits that they're learning how to do hops in space. How do hops grow in space? Because, you know, we like to drink, but we have bourbon in Kentucky. So that can be an industry that can space cuisine. Food needs to taste good for astronauts and for people that are going on space tourism experiences, and service workers like hotel, restaurants. People are going to be needed to work on the moon, work on these space stations. And then education. Education is a big one. We got research that for every aspect of our life needs to happen. We have STEM and STEAM. STEAM is STEM with arts added, which is science, technology, engineering, math. We need arts for creativity. When you're out in space, you don't know what you're going to experience. So you need to have that creative mind to be able to figure out the solution. And that's where the arts come in. That's a very valuable component. Astronaut training, we can serve as training ground for astronauts that are going up, private astronauts, as well as government astronauts and tourist astronauts. We can have analog missions as well, which analog missions are pretend missions. Commercial training, we can train people on all kinds of things from satellites, how they go together, to how to do a habitat. Mining, we have a huge portion of miners here in Kentucky, and that particular industry has imploded. Well, all these people have valuable skills, and mining is going to be a huge thing going up in the moon. Japan and China are looking at mining asteroids, mining the moon. So in order to find the water, we're going to need to mine the water to be able to use the water. Robotics and high-risk interactions when we're building space stations or we're out in space. Robotics can be the extension of us. They can build things, they can be in dangerous situations that we can't. So robotics are a major industry that Kentucky can plug into. Robotics has already been on the International Space Station and come down. Surgeries, fine-tuned surgeries, are an example of an industry that has come down and made it to where we're able to get tissue that's infected and remove it without harming the healthy tissue. And prosthetics and so farming, robotics can generate limbs. We have App Harvest out in Moorhead that use robotics in their farming practice. So robotics is a huge industry that space can bring to Kentucky. Space debris, collecting the garbage up there. It's becoming a problem and we need to deal with it. So this is going to be a huge industry as well that we can tap into. And of course, then you've got space finance and you've got space risk management such as insurance. These are new industries coming online, as well as space law. Okay, are there any questions? You know, that was kind of like a fire hose. You guys already know about space. Do you have any questions?
That process, that was a lot. There's a lot of things that did not. A lot of opportunities.
There's hardly any industry that will not be affected by space. So it is going to be impacted in one way or the other by space. And it's only growing. You know, back when we first started our space race, there was Russia and there was the US. That was it. Since the 2015 Space Act came out, we have over 70 countries now with space programs that are funneling money into their country and their businesses. So you have a huge commercial industry that we can't even comprehend how many people are in it right now. I don't think anybody's measuring it. It's so new, just since 2015. It's a new game, and it's going to be a new journey. All right. Thank you guys for being here. And it has been awesome. We'll have our first one. Go ahead and